And then, before we talk about contraception, I'm going to talk about a few ways, some of the most common ways that men and then women experience infertility, what some of the etiology is, and how the conditions are treated. And then we're going to talk about contraception in both females and males. I'm going to start briefly. I said there was one image that I forgot to show last time, and I don't want to go through the whole thing of pulling the screen back down or whatever. But remember, this is the vagina. The cervix is somewhere here, leading to the uterus. These are ovaries and fallopian tube. And this is from that website, the clitoris.com. And did they get the link yet? The PowerPoint?
The PowerPoint gets it. You didn't send it. It wasn't in the...
Oh, no, the link to this is in the PowerPoint. So you can click on the PowerPoint,
yes,
and then there was a link to the mice and...
Yes, if it's in the PowerPoint, yes.
Okay. Yeah. But the one reason I wanted to show this image is around the bladder. This is that structure I talked about, the Skene's gland, or the so-called female prostate. So I wanted to show this image so you can see where it is. And again, different women have different amounts. Some it's practically absent, and others have a pretty significant one. And I'll tell you why that's important as we go on with our review. So. And you can also go view all those images. Yourself. So if you go through the PowerPoint, on the very last slide, there's a link. If you click on that, it'll take you to the clitoris.com. So you don't have to get confused and end up on clitoris.com. That is a very, very, very different website. Trust me, you don't want to go there, especially if you're sitting in the coffee shop. All right, so here's what we're going to do first. Different colored chalk. Hormone cycle. We have our follicular cycle. Uterine cycle. And the first half, the follicular phase, is regulated by a fairly complex HPG. It's going to get more complex today. Apart from some stuff I did. So you have two HPGs. One is operating on the follicular side, where GnRH stimulates LH and FSH, and LH stimulates testosterone, which is converted to estrogen by FSH stimulating the granulosa cells. You also have, coming from the granulosa cells in the follicular phase, this inhibin that specifically is inhibiting FSH. And that's what keeps you from having more than one ovulation, more than one baby at a time. I learned in a paper I read yesterday, which by the way reminds me, I probably spend 6 hours a week studying for and reading new papers for class. I've been teaching this class for 21 years. I know you might be smarter than me, you might not need to study as much as I do, but that should give you an idea of how much you need to study for my class if I spend 6 hours. But I learned yesterday, in addition to the granulosa cells inherently secreting inhibin, that there's also evidence now that FSH, we'll add a new line there, that FSH directly increases inhibin secretion from the granulosa cells as well. So not only do you have more inhibin, because you have more granulosa cells, but FSH also directly stimulates the production of inhibin from those granulosa cells. And that's from a fairly recent paper that I found yesterday. So you have this pretty complex HPG where you're stimulating ultimately estradiol, and that estradiol is regulating this uterine cycle. Remember, it's stimulating the estrogen receptor, so it's making the uterus more and more sensitive to estrogen. The uterine lining, the endometrium, and it's making it more and more sensitive to progesterone because it induces the progesterone receptor. The follicle that grows the fastest, that obtains the most LH receptor, that expresses the most estrogen, then ovulates. Here, on about day 14. And after that, the corpus luteum is formed, and essentially this is the functional HPG. The thecal cells invade the granulosa cells. I'm not going to re-illustrate that, it's a pretty bad drawing anyway. And primarily LH stimulates progesterone production in that part of the cycle. Some people asked about in office hours and a little bit in class about PMS. What I've learned is there's not much more known about PMS than there was when I started teaching the class 20 years ago. But 80% of women experience some symptoms of PMS. In addition to the physical symptoms, these include things like mood changes and irritability and depression and loss of motivation. And about 20% of women experience those symptoms, which are known as full-blown PMS. The reasons are still unknown, but if you have depression, you're more likely to experience PMS. And if you have depression and experience PMS, you're more likely to experience postpartum depression. The thought is, which it was 20 years ago, the thought is that it's caused by the drop in progesterone just before you have your menstrual period. And the thought is progesterone, we haven't talked about it much in this class, but progesterone, in addition to maintaining the uterus, the uterine lining, to keeping it from contracting, in addition to maintaining the thickness so that the conceptus can implant, progesterone has a lot of behavioral effects in the brain. Because remember, ultimately, this cycle is preparing you to have a baby. So progesterone in certain parts of the brain makes oxytocin receptors more available. And that oxytocin, as a neurotransmitter, not as a hormone, that oxytocin receptor controls a part of the brain that controls things or regulates things like pair bonding, both to your partner as well as to your future child. So the idea is that progesterone is promoting these feelings of you want to be with your partner, you want to bond with your baby, and then when that progesterone declines, that's associated with the behavioral changes. So it's sort of a withdrawal from progesterone, if you will. And the thought is it's not how low your progesterone is, but the magnitude of the change. So somebody who has PMS and somebody who doesn't have PMS, approaching the menstrual cycle might have the same progesterone levels. But in theory, people with PMS have higher progesterone levels to start, even though they all end up low. And the idea is that the same thing is true with postpartum depression. That it's the magnitude of change between how much progesterone you had when you were pregnant, and then all of a sudden the baby's gone, and you lose that progesterone. And so you lose some of those behaviors and go into depression. In severe cases, some of you guys may know, every now and then there's this story about, there was one from South Carolina, where a woman took her babies and pushed them into the car. So a lot of times there's infanticide associated with postpartum depression. In fact, give you a historical perspective. You know how I am about words. I guess because when I was in school, in addition to SATs and GREs, when I was a kid, we had all this tracking and all these standardized tests, and most of them involved, in this vocabulary. So I like to know where every word comes from. Who knows what this word means? What's that word mean? Somebody speak. Somebody say it loud. I'm old man. Hysteria. Hysterical. What does it mean? Come on, somebody has to know what it means. Y'all took the SAT. It means like crazy, right? Crazy. But the original, the root of the word is Greek. It means of the womb. So for example, if you are hysterical, you get a hysterectomy. Who knows what that word means? Raise your hand if you know what the word means. It means you have your uterus and ovaries removed. So in fact, it used to be thought that the source of mental health problems in women was their reproductive organs. So if you had PMS, or if you had postpartum depression, the treatment was a hysterectomy. And when I say used to, I mean that in my lifetime, my mother, who suffered from depression, in 1973, had her uterus and ovaries removed because she had postpartum depression after my younger brother. She's still depressed. And probably what she viewed as the loss of her womanhood and how it affected her marriage made her more depressed. But that used to be the treatment. I guess the take-home message is, for future doctors and future patients, just because something's happened in the medical field doesn't mean it's right. The treatments now for PMS are, in some cases, antidepressants are given. And in other cases, birth control pill, the classical birth control pill, and others, which we'll talk about in part C, are given. And I'll tell you why those presumably help with PMS. So after that stage, questions or comments? Yeah?
Has progesterone ever been studied as an antidepressant drug?
I don't think so, no. Not to my knowledge.
Does that work in the same way at all?
Well, as you'll see, as I said in a second, one of the treatments for PMS is to go on birth control pill. And essentially that's the reason why, because you're controlling the progesterone levels, whereas naturally you have no control over how high your progesterone levels get or how low they drop. But you can regulate that when you're on birth control pill. So that's one of the reasons that birth control pill is used as a treatment for people with PMS. So at the last stage of our cycle, you go through your menstrual period, and that's the one that I told you won't find in the books. That's regulated by prostaglandins, in part. The contraction uterine cramping that some women experience during their menstrual period is due to prostaglandin causing the myometrium to contract as the endometrium is leaving. So Lisa, is Lisa here? Lisa, so I looked this up. You asked me about the aspirin thing, right? Okay. So I told you, because it used to be that you take aspirin or Tylenol or some other drug that blocks prostaglandins to treat a menstrual cramping. And in office hours, Lisa asked, wouldn't that make me have a longer menstrual period? So I looked this up. I don't have a scientific answer for you, but I went on one of these, like, what do you call them? Where women write in and ask each other questions and things like that. So, the things I do for you guys. So apparently, it stops the cramping, but it makes your period shorter, because remember, aspirin is also an anticoagulant. So it, quote, thins your blood. So you have a heavier flow, but it's faster. Like there was one on the forum about a woman whose wedding was coming up, and so she wanted to make sure her period was over by the time, and she took aspirin. But there's also a doctor that came in and said they don't recommend using aspirin for that very reason, that it induces more bleeding than you might normally experience. So probably a better option would be things like Tylenol, which actually block COX-2, but also don't act as anticoagulants. So see, I checked that one. Yeah, that's all I want to say about the cycle for now. The next part, as we did with males, was to talk about arousal and erection and finally orgasm. I get criticized once. I said, well, I don't spend as much time on women arousal and orgasm. But essentially the mechanisms are the same. So I showed you the structures. There's a corpus cavernosa and a corpus spongiosum. And those, the first step, just like it is in men, is that oxytocin as a neurotransmitter, and here I'm going to read you. Oxytocin as a neurotransmitter, you're stimulated somehow, that's up to you. But oxytocin as a neurotransmitter in the brain is the first neurotransmitter that conveys to you that you're being aroused. Then there's another neural signal, and just like in men, it goes down the spinal cord. There's another neuron, and then there's a peripheral neuron using glutamate as a second messenger that ultimately stimulates the relaxation of the corpus cavernosa and spongiosum in the female, the same as it does in the male. And now I want to read you, somebody asked an officer about this too, I want to read you this thing that really gets me going. So oxytocin is a neurotransmitter in the brain, as I told you, is involved in pair bonding. That's one neuron to another. That's not like it's flooded your whole brain. That's a neurotransmitter, one neuron to another. In another part of the brain, oxytocin is a neurotransmitter, one neuron to another that's transmitting the arousal signal. But it has nothing to do with oxytocin released from the posterior pituitary that will ultimately lead to orgasm. So don't ask me why I have this. But in 1990, it's about as old as that VHS tape I need, in Mademoiselle, there was an article that I want to share with you related to this issue. The article is called The Love Hormone. This was in 1990. The subtitle of the article is Why You Keep the Creep You Sleep With. Give me a second, I had it marked. And anyway, it goes on about how you can be mistreated by a man, but then you'll end up keeping him if he makes you have an orgasm. And the premise is, in this article, Oxytocin, the Love Hormone, the premise is that the oxytocin that's released during your orgasm ultimately causes you to pair bond with him and not want to leave him. I had it marked and now I lost it. Oh, here it is. It says, you know the story. On the first date he was passable. On the second he was okay. Then you had sex. Boy, did you have sex. Now suddenly you can't stand the thought of him ever leaving your side. Your body tells you you're in love, even though your brain is saying, oh, he's all wrong with you. What's going on there? In a word, oxytocin. A hormone that stimulates the smooth muscle and sensitizes the nerve. So then I thought, man, things must have changed. And so again, don't ask me why I have this. I don't regularly read these things. Just because I do my nails doesn't mean I read Glamour and Mademoiselle. But in 2012, this article comes out. Why breakups are harder, all about you. What are some of the things they say? I know the headline sound. Oh, wait, here's one. It's misconception that women get super connected to the people they sleep with, but that men never do that needy emotional thing. In truth, sex releases bonding chemicals, oxytocin, into female and male brains. And so the idea is, again, if you have an orgasm with somebody, you're stuck. The history of that idea is that there was a study back when I was in college at least on voles. And there's a vole that's monogamous. And in the monogamous vole, and then there's one that's not monogamous, a group of researchers did studies and found that this oxytocin was involved in the pair bonding when this female vole met the male vole. So the conclusion was that there's oxytocin that causes pair bonding, and then that's why the female vole ends up wanting monogamy. Several problems. One is, nobody ever studied the male voles to ask if the same thing was going on. So there's a bias study in the first place. The second one is, they're making a leap between the oxytocin that's involved in pair bonding as a neurotransmitter, and the oxytocin as a neurotransmitter that's involved in arousal. It's two different things. That's like saying just because glutamate, the neurotransmitter, controls learning in my brain, that every time I learn something, I'm going to get an erection. They're two unrelated things. It's silly, but that's what people have been taught, and glamour and Madam was us. And as scientists, these are things that you have to explain to people that don't have this information. The other ridiculous thing is the oxytocin that's released to the posterior pituitary, when you have an orgasm, when you climax, does not go back into the brain and then make you pair bond and get aroused again. In fact, it's just the opposite. Once you have an orgasm, there's usually a refractory period. But somebody asked me about it in office hours. And that refractory period is defined as the amount of time that it takes you to get another erection after you've reached climax. That varies between people. I read that some people can only have one orgasm a day. Guys? And then some people, there was a guy who used to sit in the back last time, we called him Refractory Sam, because anytime he came up, he would raise his hand and say, that doesn't happen to me, I can do it. TMI. But in fact, the refractory period varies. And the refractory period, remember everything that happened, when you get the video, look at it. Remember everything that happened to relax the myoepithelium and cause you to get an erection? Talk about women in a second. When the oxytocin comes along, remember how it works? It does the opposite. It causes contraction. It causes actin and myosin to interact, and so you lose the erection once you have an orgasm. And so it takes time for those receptors to turn over. And the longer you do it, the more times you do it, the longer it takes. Each time it takes longer for those receptors to turn over. This came up in office hours too. There's other environmental factors that can impact the refractory period. You guys know what the Coolidge effect is? So there's a story where President Coolidge, I've heard different versions of it. One he's at a farm, one they're at a zoo. But anyway, let's go with the farm version. And on the farm, the first lady sees this rooster copulating with his hen. And she says, wow, can he go on like that all day? To the farmer, and he says, yes. And she says, you should tell the president that. So the farmer goes over to the president and he says, the first lady wants you to know that that rooster can go on like that all day. And the president says, with the same hen? The farmer says, no. You should tell that. So it became known as the Coolidge effect. Your refractory period actually decreases if you didn't have a second partner. So there's some other thing. Now, here's the other bias. Nobody ever studied the Coolidge effect in females. Right? So there's this idea that men want more women and women want to be monogamous because some of it's a bias in how the studies are done. You also may have heard that there's no refractory period in females. I think that's probably not true. I think it's probably just more obvious in men when you have a refractory period. It takes a longer time for you to get an erection. But with prolonged sexual activity, in women, the vagina becomes dry. And remember that the lubrication of the vagina is because of blood rushing to the vagina and plasma coming out. The same way blood has to rush through and plasma comes out to give you an erection. So even though you're still able to do stuff, it doesn't mean that there's not a refractory period. I think that's all I want to say about that. So we're not cutting women short in terms of on their arousal. climax stuff. It's just that the mechanism is still the same.
Why doesn't Viagra work for women then? With all the mechanisms?
Who says it doesn't?
The people who market it said women can't take it.
It depends on what you're using it for. It should do the same thing in men in terms of having the blood flow to the area. You know, in fact, most of what we know, or much of what we know about arousal and especially ejaculation actually comes from women and not from men. Oh, and by the way, the reason I mentioned the skin glands, because somebody always asks me this, some women actually, when they orgasm, ejaculate fluid that comes from the skin gland. And the fluid is milky and has some of the same constituents as prostatic fluid that's in the semen. There's also something called coital incontinence. So someone can expel fluid because they empty their bladder due to the contractions at orgasm, contractions that are on the vagina and uterus. I remember when much of this stuff was discovered, actually, how oxytocin affected the corpus cavernosus and spongiosum. It wasn't done in men, even though we use it to understand men, and even though we use it to understand how Viagra works, it was done in women. I was at a meeting in Asia. A guy from Korea gave a talk where he showed data, where he did little electromyograms, and he showed data on what happens when you apply oxytocin to the corpus cavernosus of the clitoris. He was doing all this in a petri dish. And I was there with many famous reproductive biologists. And I remember we were all sort of snickering at this guy stimulating clitori in a petri dish. Yeah, because it sounds funny. And then finally somebody asked, where do you get all the clitorises? And he said, well, for some women, they're too big. And so they come in, this guy's a medical doctor. He said, they come in and I cut them off. And it turns out, there was a little bit of language barrier. It turns out, as we questioned him more, it was actually men who would bring their wives in, essentially because they didn't want them to cheat. So imagine a world, and that's where most of those studies come from. So imagine a world where your wife, guys, could take you to the doctor and have your penis cut. That's the world we live in. 130 million women in the world have their clitoris removed. Mostly in 29 countries, North Africa, throughout North Africa, Middle East, and Asia. If you go to theclitoris.com, there's a section in there that you can click called the clitoris at risk. 3 million women a year through rituals have their clitoris, and in some cases their labia removed. And at least in one place, a culture where I've actually been to, where not only the clitoris and the labia removed at birth, but they sew the vagina shut except for a small hole, so that when a woman gets married, usually about age 12, her husband can cut it open and know that she's never been touched. So let's now go back to the physiology and talk about some of the reasons that both men and women can experience infertility. In men, your sperm count can go down for a number of reasons. Not all women. For example, the sperm have to develop a couple degrees cooler than your body temperature. So if you wear tight shorts or tight pants, potentially the sperm count goes down. If you're kicked hard enough, everybody told you that the testicular tubules, there's a blood testis barrier. The testicular tubules protect your sperm from your blood. So your body, the rest of your body, your blood has never seen your sperm. But if you're kicked hard enough, for example, or if sometimes if you have a vasectomy, or if you've been exposed to another man's sperm, you can develop antibodies to your sperm and actually become infertile. So testicular injury can cause you to be infertile. In other cases, if your testosterone levels are simply too low, you can become infertile. And that can be caused by a number of things. Bad news for you guys. Alcohol will lower your testosterone levels in fertility. My son's going to hate this one. Marijuana. Lower your testosterone and your sperm count and can make you infertile with prolonged smoking. And I just saw a study yesterday that the sperm themselves are affected by chemicals in the marijuana so that they apparently swim really erratically and die out before they actually get anywhere. So it might mellow you out, according to my son, but that's the opposite effect of your sperm. There's another condition in men. Called Sertoli cell only syndrome. That's usually linked to a chromosomal deletion. And the men have sperm. I mean, they have the germ cells, but they just don't develop. They mostly have Sertoli cells in their testicular tubules. There is a treatment for that. They can actually go into the testicular tubules and take the sperm and actually put all the components in there and develop the sperm and then do something in vitro if you're trying to reproduce. Those are probably the biggest causes in males. Females, as you might guess, is a little more complicated. That chalk isn't working. There's a number of things in females. Oops. Hyperprolactinemia can cause infertility. That's where your pituitary, sometimes because of a tumor, makes too much prolactin. And I know prolactin is required for the LH receptor, but prolactin, and the mechanism is not known, I just looked this up yesterday, still not known. Prolactin inhibits LH. So if you look at the top there, if you have too much prolactin, you don't get the LH surge and you don't ovulate. That's also what happens when you're lactating, when you're breastfeeding. There's something called lactational amenorrhea. And it's because prolactin, again, nobody knows how it does it, but prolactin inhibits LH so you don't get the LH surge. You can also have amenorrhea, which means you don't menstruate, which means you aren't ovulating. If you're stressed, so CORT can block LH, CORT can block your steroid production, CORT can block GnRH, and my colleague here at Berkeley showed at least in animals, CORT can turn on GnIH, which will block GnRH so you don't go through a cycle. In addition, there's a hormone called leptin. It was discovered, I think I was a professor when it first was discovered. And it comes from fat. And one of the things that leptin does is it turns on the HPG. It's kind of saying you have enough body fat, you can reproduce. If you have very low body fat, like my daughter, who was like this incredible athlete and was solid muscle, if you have very low body fat, you can experience amenorrhea. If you are anorexic, or if you are on some crazy diet, and you have low body fat, sorry, I shouldn't say crazy diet. If you're on like a serious diet, and have low caloric intake and low fat, you can experience amenorrhea because the leptin goes down when your fat goes down. There are obvious treatments for amenorrhea depending on your condition. Changes in diet, somehow relieving the stress. There's something called endometriosis. Who's ever heard of it? Endometriosis is where you develop endometrial tissue in parts of your body other than your uterus. Some people think it starts because you're menstruating And the endometrial tissue, instead of leaving your body, actually goes the opposite way of the fallopian tube and ends up in your body cavity. That tissue can grow on your bowels, on your intestine. It can grow on the tissue lining your pelvis. It can grow on your ovaries. And every month, when estrogen stimulates the endometrium of your uterus to grow, it stimulates the endometrium in other parts of your body to grow. Apparently, it's very painful. And when you bleed inside because you have endometrial tissue responding to that same cycle that's not in your uterus. And then that blood gets trapped in your abdomen, in your abdominal cavity, because there's no way to get out. It can cause infertility because if the endometrium is on your ovary, when you're now bleeding from your ovary, it can cause scarring on your ovary that can lead to infertility. Sorry, I forgot the word for a second. PCOS. Remember one time I told you that this was a reciprocal relationship? I learned, I teach, you learn, you teach. I learned about PCOS because every year a woman came to office hours to talk to me about PCOS. It's the most common cause of infertility. Something like up to 20% of women get PCOS, polycystic ovarian syndrome. It's genetic, there's a genetic component. There's been all these twins that grew up in different places studies. It mostly affects white women. And in some cases it's associated with obesity. And what it is that you have follicles. You end up with follicles that don't ovulate. So you develop these non-ovulatory follicles. Remember I told you you're supposed to do a treatment, they're supposed to go away. In PCOS, and nobody knows what causes it, and there's no treatment. Well, there's a treatment, but there's no cure. Treatment's birth control pill, just like it is for endometriosis and everything else I told you. These non-ovulatory follicles, though, stick around, and they start producing testosterone. What I didn't tell you, for example, is even though these are the major hormones, all of the precursors also leak out. So even when you're in this phase and you mostly have estradiol, there's some pregnenolone, some progesterone, some testosterone, you know the whole pathway. There's some of all of that in your body. But when you have PCOS, the non-ovulated follicles primarily produce testosterone, which is important, right? Testosterone actually is responsible for libido in women and in men. So you should have some, but you produce so much testosterone that you develop facial hair, you develop acne. Some women have clitoral enlargement, so the clitoris starts to respond and grow. But also because you have so much testosterone, you stop menstruating, because it has a negative feedback effect just like it would in a male, right? Here's our little simple thing that we do. So essentially, with PCOS, you end up with an HPG that looks rather masculine. So again, you get facial hair, in some cases body hair, acne, but also the testosterone is feeding back so that you don't ovulate, you don't go through menstruation. What makes matters worse with PCOS is that the testosterone, the excess androgen, causes you to gain weight the way a man would. Causes you to gain weight mostly above the waist. And that type of body weight gain is associated with, and I hate the terminology, type 2 diabetes. Type 2 diabetes is when your body, your cells, don't respond to insulin. So when you have glucose, you guys read that? It's boards. So when glucose goes up, insulin goes up, but the insulin doesn't stimulate the glucose uptake. So now you have high androgens, you're experiencing masculinization, and now you have a type 2 diabetes associated with masculine type body fat storage. What's more is, and they still don't know why, but insulin, am I going too fast? Slow brother down. You guys know I get excited, you guys slow me down. The insulin binds to the non-ovulated follicles and acts like a gonadotropin. So you get non-ovulated follicles that produce testosterone that inhibit your menstrual cycle, that cause you to develop type 2 diabetes, and the insulin stimulates more testosterone, which causes you to get even more masculinity and male type weight gain, which causes the diabetes to get worse, which causes more testosterone. Yeah,
How's the insulin increasing testosterone?
I just said I have no idea. I spent all night last night looking it up. There's one suggestion that it works through a different second, it doesn't work through IRS and a normal insulin receptor. It works through some other second messenger system that I don't even remember, so I'm not going to make you memorize it. It's something I never heard of.
Which organ might be that?
For this,
Yeah.
it's the non-ovulated follicles. So insulin's acting as a gonadotropin. Yeah.
How does the above the waist weight gain cause diabetes?
Man, I have no idea. So typically, type 2 diabetes is associated with above the waist weight gain. I'll tell you my theory later in the course, but it's just my theory. So I'm telling you that. And when you work on it and discover that's true, you give me credit. Again, it turns out this is the most common PCOS, the most common cause of infertility. And something like 20 to 30% of women will experience it. There's no cure. The treatment is birth control pills. We'll talk about why that is for a second. You guys might not realize this. I think that's all I'm going to say about that. You guys might not realize this, but chemical birth control pill is like available in my lifetime. We barely have a generation of data. I was born in 1967. The first birth control pill and experiments came out in 1962. The studies were done in Mexico with steroids extracted from yam. They brought the pill back to the U.S. to Boston, and the laws wouldn't allow them to test it here, so they went to Puerto Rico, and they tested it on women in Puerto Rico. I want you to think about that. Wouldn't allow it to be tested here. Wouldn't allow it to be studied here in the first place. They did it in Mexico. They developed it, brought it back to the U.S., they made it go to Puerto Rico, and then they allowed them to come back and test it on people in the U.S. The classical, what I call the classical birth control pill, these are structures that you don't have to memorize. You've already memorized everything you have to memorize. In fact, you're going to see that I don't have them all memorized. This other, I don't even know how to do this. The classical birth control pill is a mixture of these two compounds. I'll tell you what I mean by classic. Ethinyl estradiol and norethindrone. Now here's where you're going to hate me. Norethindrone is called a progestin. When you're talking about synthetic chemicals, I made you memorize structures and tell me which are progestins, which are etc. That's structurally based. But for synthetic chemicals, they use, I don't make it up, this is how they did it. They use functional. So that's not a progestin by what I made you guys memorize. natural steroids go a different route, right? It has to have 21 carbons, right? No hydroxy on the 21, no hydroxy on the 11. It's defined differently for synthetics. Why do you think they use synthetics? There's 3 reasons. One of them's not scientific.
You make money off of them.
That's one, right? That one, not because you can patent it. You can't patent testosterone, can't patent estradiol, but you can patent ethinyl estradiol. What are the other reasons though they use it synthetic?
Synthetic could bind better.
That's right. Okay, synthetic could bind the receptor better. Okay, you got 5 more points. What's another reason? Because that's not the reason. But that's a good answer. Yep.
Is it because it's agonist in some tissues and antagonist in others?
No, that's a good answer. That's not it. Yep.
You can mass produce it easy.
Nope. Think about the definition of a steroid. What else?
You don't want it to do something that you didn't predict it would do.
What?
You don't want it to do something you didn't predict it would do. If it's gonna circulate all through the blood, you wanna.
But that'd be easier with the normal estradiol. This is synthetic chemical.
Oh.
Well,
It's already synthesized, it doesn't
you can synthesize estradiol.
Is it degraded?
Ha! That's right. So this, I can tell you, I don't know about humans, but I can tell you, if you give a frog estradiol, it's done within minutes. You give a frog ethinyl estradiol, it's in the water for weeks. And it's because this ethinyl group makes it hard to metabolize. Because remember you metabolize. Remember I talked about you add these glucoses and sulfate groups? So this group, I'm going to use a word that I don't, this group sterically hinders the degradation. You know, I already told you I was bad in chemistry. Did I use that word right? So they're steric hinders. So these don't degrade as well. So they stay in your body for longer. So that's why primarily they use these synthetic compounds. They don't bind the receptor better, but they're in your body for longer. And the way this works is the classic pill. And believe it or not, this is all that was available to me and my wife back in the day. We didn't have all the other stuff we talked about. But what it's doing is it's preventing the follicles. It's preventing the follicles from developing through negative feedback. Through negative feedback. Through negative feedback. Anybody got something to say about that? You guys need to challenge your brother a little more. No problem? All right, let's keep talking. So the pill is working by negative feedback, preventing from any follicles from developing. Through negative feedback. And then it's preventing ovulation because through negative feedback, the LH surge doesn't occur. And so what's happening is when you have the little, I don't know how it looks like now because my number's retired, but you have like a little case with these pills in a circle. Each day you're taking a different pill. It's a different combination. And for each person, it's a different prescription. Okay. What you're doing is the first set of pills is a little bit of estrogen and progesterone. So you're going through a fake follicular cycle, but the hormones, well, in this case, the synthetic hormones, are not coming from your body, they're coming from the pill. And the negative feedback is preventing the LH and FSH from rising. You build up a uterine lining because there's a little bit of estrogen in the pill. But then before you can, well, one, you don't have any follicles anyway, and then that estrogen and progesterone and negative feedback blocks the LH surge. The last part of the cycle is mostly progesterone. So you've gone through a little fake cycle, and then you have like 4 sugar pills or something like that that allows you to get your menstrual period.
So is it negative feedback because you put in so much estrogen that you're finally to the negative feedback point?
Ah, there you go, yeah. No, I think it's mostly because of the progesterone in the early pill that you wouldn't see in a normal cycle. I'm gonna let the rest of y'all ponder that. Me and Dina were right here. So the idea is, and many people think, now this is debatable. If you go on these ladies' forums like I go on to see. So some people use this kind of birth control pill because some people think it's actually a healthy thing to have a menstrual period. You're like losing cells, you're taking out potential cells that might later become involved in uterine cancer or something. So some people think it's actually a cleansing thing. And so some people want to have their menstrual period and would choose to be on this type of birth control. Now, philosophically, I would have to say, I gonna get in trouble or not. It's not natural for any, well, one, we're weird. There's very few other animals that actually have a reproductive event once a month. Most animals are reproducing once a year. And it's very weird for any animal to forego reproduction every month for 15, 20 years. So it's debatable whether or not that's the natural thing to do, that you should go through menstrual cycles. And some people feel that that's important. And so would choose this type of birth control. The other thing that's important to know is the reason this is used to control endometriosis is because you can give a prescription that limits the amount of estrogen so that the extra endometrial tissue doesn't grow so much. You can use it to help regulate menstrual cramping and PMS because you can regulate the amount of progesterone and the progesterone drop. It's not up to your body. You can regulate the PCOS because now you've, through negative feedback, blocked the LH that's stimulating the non-ovulated follicles that are producing the androgen. So that's why it's prescribed for so many different things. Does that make sense? Then, I'm going to put up two molecules on the board. Again, if I look at notes,